Okay, we are going to be looking at physical and chemical changes in chemistry. As you can see, a lot of different things on the screen here. Top right is a precipitate. Then you got breaking, we got boiling, burning, oxidation. Lots of different things here. Let's dive in. So when we're looking at physical change, it is a change to a substance that does not change the identity. It changes the size, shape, state of matter, but all of these are considered physical changes. It does not change it on a molecular level. There are many different words that mean to change size and shape, like stretching, for example, as you see there, compressing, shattering or breaking, tearing, ripping, breaking, I already said that, dissolving. That's a little confusion. You take sugar, you mix it into water, all of a sudden you're not really seeing the sugar anymore. But if you were to look at that water, you'd be able to see the sugar molecules and you'd still be able to see the H2O. It did not combine and make a brand new substance. So all it did really is change the size and shape and make it, and so that's why dissolving is a physical change, not chemical. There is warming and cooling that happens both for physical and chemical. We'll dive into those, but literally if you're just, you have a hot plate and you have water and you turn the hot plate on, it's going to make that water hotter. So you're going to notice the temperature increase, but that was because of the heat that was applied. Or if you take that thermometer and put it in water and then add ice to it, you're going to notice the decrease in temperature. That is just physical change. So then we have some other changing states of matter. We have melting, is when solids become liquids after they warm up, like you can see here with this glass. And then we have freezing. Clearly, you know what that means. We have evaporation and condensation. All of these are changing states of matter. Water is the best example of that because water can go from ice to liquid and evaporate and become water vapor. But it's all, no matter what state it's in, it's still water molecules. Dry ice is good. A good example. It's solid carbon dioxide. It's very cold. When it's called subliming, when it turns into a gas. But it's called sublimation is the word, and that is a state of matter. We're not talking molecular change. So now that we understand all the physical changes, and you're going to have a lot of opportunities to look into those and differentiate the two, let's talk about chemical change. There's a lot of evidence for chemical change, but when you go back to a chemical formula, like for example here you have your reactants, we have CH4 plus O2, and you have your reactant yielding a new product, a new substance forming, which would be HO2 or H2O plus CO2. So there's always going to be a sign that chemical change happens. So what I'm going to ask for you to do right before we start and dive into some of these, I'm going to ask you to remember an acronym. It's going to be please excuse coughs, burps, sneezes, or chunks. Yep, I said that. I'll say it again. Please excuse coughs, burps, sneezes, or chunks. Take the first letter, and all of those mean something, okay? So the please is precipitate. We've already shown a picture of that. It's when you take, a great example is if you take two clear liquids, mix them together, and a solid forms. So that would be evidence of chemical change. The excuse would be endo or exothermic reaction. That is when you mix two chemicals together, two reactants, you mix those together and they yield a new product. You know a new product has occurred because the temperature has changed simply from mixing the chemicals. So understand that that is an endothermic or exothermic reaction. Exo means to release, so exo is when heat is released, and endothermic would be when heat is absorbed. The best example for that is if you take one of those ice packs and you break it and it gets really cold. That's going to be a great example of an endothermic reaction. Heat is absorbed and you notice a temperature decrease. Coughs could be color change, great example here, but I don't really like this one because this is also an example of something else. Oxidation, but and that's for the O for or. Please excuse coughs, burps as bubbles. Sneezes, smells. So if you mix two chemicals together, you get an odor from it. That's evidence of chemical change, like rotting milk. You know, you can absolutely smell the chemical change of that. Burps, sneezes, or chunks. The last one is going to be combustion, which is, you know, like an explosion, like fireworks, or an explosion from a bomb or something going off. But here's some examples, some pictures of that. There's the precipitate again. Evidence of chemical change. Evidence that a new substance is formed. There's your bubbles. StarTest loves bubbles. You can always find, you know, I'm telling you, it's always the case. You can look for bubbles in one of your answers on the StarTest, especially it asks about what's the evidence of chemical change. Just look for bubbles, mark that, move along. I've been doing this for a long time, so yeah, it's a good example of a question you'll see on a StarTest. There's your exothermic and endothermic reaction. There's your endothermic. Heat being absorbed, temperature decrease, which again differentiate between the two, being warmed up and releasing heat. There's a fine difference, so make sure you understand those differences. Light being produced, absolutely evidence of chemical change. But at the end of the day, the number one way that you can tell that a chemical reaction has occurred is because a new substance has been formed. And that, my friends, is the end of your physical and chemical changes when when elements undergo some type of change experience.